Histograms.
Video, we're going to learn about histograms. We're also going to learn what is the difference between a histogram and a bar chart, and why histograms are used to represent data that is in groups that are uneven. To start off with, we're going to draw a bar chart to represent this data, which is the height of people in a class. Let's draw our set of axes. First bar representing the heights 100 to 120, frequency 20. Second bar representing heights from 120 to 140, frequency 25. Third bar representing heights from 140 to 150, frequency 30. Fourth bar representing heights from 150 to 160, frequency 25. And the last bar representing heights from 160 to 200, frequency 20. The problems with this are the data is continuous, so there should be no gaps. Heights 150 to 160 has the same height as heights 120 to 140, even though it represents a smaller range. A histogram will correct both of these problems. So if we draw a histogram to represent this data, to take into account the size of the group, we calculate the frequency density. Frequency density is equal to the frequency divided by the class width. So the frequency density for the first group is 20 divided by 20, which equals 1. The frequency density for the second group is equal to 25 divided by the class width of 20, which comes to 1.25. The frequency density for the third group is 30 divided by the class width of 10, which is equal to 3. The frequency density for the fourth group is equal to 2.5. And the frequency density for the last group is 20 divided by the class width of 40, which comes to 0.5. We can now draw this on a histogram. So the heights go on the x-axis, and on the y-axis we have frequency density, not frequency. So the first group, 100 to 120, frequency density 1. Second group, 120 to 140, frequency density 1.25. Third, fourth, and the last group from 160 to 200 has a frequency density of 0.5. So there is the histogram. No gaps. With a histogram, it is the area that represents the frequency, not the height. E.g., the first group is a rectangle measuring 20 wide by 1 high. 20 times 1 is 20, so there are 20 people in the group. The fifth group is a rectangle measuring 40 by 0.5. 40 times 0.5 is 20, so there were 20 people in the group. Let's do another one. This one is regarding speed. To To take into account the size of the group, we calculate frequency density. Frequency density is equal to frequency divided by class width. So the first one, the frequency density is 10 divided by 40, 0.25. The second is 15 divided by 10, which is 1.5. The third is 18 divided by 10, which is 1.8. The fourth is 20 divided by 5, which is 4. The fifth group is 35 divided by 5, which is 7. And the final group is 20 divided by 10, which is 2. We can now draw this information on a histogram. The speed goes on the x-axis. On the y-axis goes the frequency density. So there's the first group from 0 to 40. There's the second group from 40 to 50. The third group from 50 to 60. The fourth group from 60 to 65. The fifth group from 65 to 70. And the final group from 70 to 80. Remember that area represents frequency. So group 1 is 40 by 0.25. 40 times 0.5 is 10. So 10 people in the group. Group 5 is 5 by 7. 5 by 7 is 35, so 35 people in the group. Plenary. The table shows information about the size of eggs and percentages of eggs sold in a supermarket in the UK. You may assume no eggs are less than 35 grams or more than 103 grams. Draw a fully labelled histogram to show the data. So we know that the smallest is 33. We know that the largest is 103. We can now work out the frequency density. The first one is 0.5, 10 divided by 20. The second works out to be 2.2, 22 divided by 10. The third is 5.3, 53 divided by 10. And the last one is 0.5, 15 divided by 30. If we draw that on a histogram, the eggs weight goes along the x-axis and the frequency density goes on the y-axis. So we have learned how to plot histograms of sets of data. We have seen how they are different to bar charts. We have learned what is meant by frequency density. We have shown that on a histogram, area represents frequency, not height.